America spent $2 million per missile developing the weapon that would destroy Iran's nuclear program. Iran spent $400 per cubic meter of granite to make sure it never would. One nation paid for precision, the other paid for depth. Only one of those purchases worked. In 2020, American defense analysts published a classified assessment later leaked to the Washington Post. Its central conclusion: Fordow, Iran's primary uranium enrichment facility, is probably survivable against conventional U.S. strike packages. Not definitely, probably. After 30 years of sanctions, 5 administrations, 12 diplomatic frameworks, and 3 generations of increasingly expensive bunker-busting munitions, the answer the most powerful military in history had produced was probably. Here is the paradox this video is going to solve. The United States has spent an estimated $100 billion across 3 decades on the military and diplomatic architecture designed to neutralize Iranian nuclear infrastructure. The facilities absorbing that expenditure were built into granite mountains using excavation techniques borrowed from Cold War Soviet doctrine, updated using American weapons specifications as the primary engineering input. A $100 billion problem, solved with geology, patience, and a calculator. How does a mountain defeat a superpower? And what did it finally cost when someone found the answer? We are going to answer both, but not yet. Because until you understand exactly how completely Iran out-engineered 30 years of American planning, the solution will not make sense. And the solution is the part that should concern you most. This is Future Blueprint. We do not cover wars, we cover the engineering underneath them. The equation starts 90 meters inside solid granite. Iran operates an estimated 80 to 100 confirmed hardened underground military sites. The most significant sit between 70 and 90 meters inside the Alborz and Zagros mountain ranges, geological formations composed primarily of granite and crystalline limestone, with compressive strengths between 100 and 250 megapascals. For reference, reinforced concrete achieves roughly 40 megapascals. The mountain is 2 to 6 times harder than the hardest man-made material a bunker buster will encounter. Iran did not build stronger walls. They found harder rock. This is the distinction that 30 years of American procurement planning consistently failed to operationalize. Every generation of bunker-busting munitions was designed against concrete specifications. Fordow is not a concrete problem. It is a granite problem. And granite does not behave like concrete under penetrating munitions. It behaves like granite. The energy from a penetrating warhead disperses laterally through the crystalline matrix in microseconds before it can concentrate at the facility walls below. Physics absorbs the expenditure that engineering cannot. Iran's engineers understood this in the early 1990s. The sites chosen for primary nuclear infrastructure were selected not by political geography, but by geological survey. Fordow sits inside a mountain near Qum, specifically because the granite formation there reaches the surface at the correct depth. The facility location was a material science decision. Here is the financial architecture that makes this humiliating. Total Iranian investment in hardened mountain-based military infrastructure across 3 decades, estimated at $15 to $20 billion. Funded through pre-sanctions oil revenues, Russian dual-use technology transfers, and a construction doctrine borrowed directly from Soviet Cold War engineering manuals. The same manuals that taught Moscow how to survive American nuclear strikes. The USSR did not survive. The doctrine did. Iran purchased it for a fraction of what America had spent trying to make it obsolete. But the money is only the foundation. The engineering adaptation is what changed the calculation permanently. And this is where analysis consistently stops too early. After every publicly documented American and Israeli strike on hardened infrastructure, the Osirak reactor in 1981, Syrian facilities in 2007, the public disclosure of GBU-57 development timelines in 2009, Iranian military engineers conducted formal penetration assessments. They did not guess at American capabilities, they calculated them. Published specifications, independent structural analyses, and, critically, American defense budget line items that revealed which munitions were in development and therefore which depths were not yet reachable. They built Fordow's centrifuge halls at 90 meters in 2007. The GBU-57, America's most capable conventional bunker buster, reached initial operational capability in 2011. Its published penetration against compressed earth, 60 meters. Against granite, classified, but independent analysts estimate 30 to 40 meters. Iran had built beyond the weapon's reach 4 years before the weapon existed. They used American procurement timelines as a construction schedule. We still have not told you what America finally tried. That is deliberate. Keep watching. The GBU-57 massive ordnance penetrator is the largest conventional bomb ever built. 30,000 pounds of Eglin steel alloy, GPS-guided, designed to penetrate 60 meters of compressed earth before detonating. It requires a B-2 Spirit stealth bomber, $2.1 billion per airframe, to deliver. The development program cost an estimated $3 billion across 15 years. It was conceived specifically because analysts recognized in the early 2000s that no existing munition could reach Iranian facility depths. The United States spent $3 billion building a weapon for one target, then discovered the target had been built 4 years earlier at a depth the weapon could not reach, using geological material the weapon was not designed to penetrate. Here is the number that reframes everything. At Fordow's documented depth of 90 meters inside granite, the GBU-57's effective penetration, accounting for material composition rather than Earth-equivalent calculations, leaves an estimated 50 to 60 meter gap between detonation point and centrifuge hall. Not 30 feet of sand like in Gaza, 50 meters of granite. A gap that no conventional munition currently in any arsenal can close, because closing it would require a warhead large enough to trigger international legal frameworks around disproportionate civilian impact. Iran did not build a facility that was hard to destroy. They built a facility that was impossible to destroy, without political authorization no democratic government would grant. They used the gap between military capability and political permission as a construction specification. $30 billion in American strike architecture, neutralized by 90 meters of pre-existing mountain. We still have not told you what finally worked. Here is what you need to understand first. What worked was not in the original operational plan. It was not what the engineers had designed for, and its consequences are still compounding in ways that should alarm anyone running the next set of numbers. The facility's survival was not the expensive part. The expensive part was what it triggered. Every year, Iranian nuclear infrastructure remained beyond conventional reach, extended the diplomatic timeline. Every extended year of unresolved status required American forward positioning in the Persian Gulf, carrier strike group deployments running approximately $6.5 million per day, sustained across decades. From 2003 to 2023, roughly $47 billion in Persian Gulf naval operating costs alone, attributable substantially to the Iran deterrence mission. Add 3 rounds of multilateral sanctions architecture costing the global economy an estimated $50 to $80 billion in disrupted trade flows. Add Israeli defense budget increases averaging $2 billion annually above baseline from 2010 onward, driven primarily by the Iranian threat calculation. One construction decision made by a geological survey team in the early 2000s produced consequences denominated in the hundreds of billions. The leverage ratio is not 50 to 1, like in Gaza, it's civilizational. Iran exchanged $20 billion in construction for a strategic position that forced America into a corner with 3 exits: ground invasion, nuclear strike, or negotiation. 2 were politically impossible. 1 became the Iran nuclear deal, a diplomatic outcome produced entirely by a construction project. Within a decade of Fordow's public disclosure in 2009, military engineering departments across NATO, South Korea, Japan, and, this is the part nobody says out loud, in Tehran's own war planning ministries were publishing Iranian mountain basing doctrine as a formal case study in geological deterrence. Their shared conclusion was not about Iran, it was about the next conflict. Underground infrastructure built into sufficient geological mass is a category of military asset that conventional air power cannot neutralize at any politically sustainable cost ratio.
That conclusion is sitting in planning documents in Pyongyang, in Beijing's 2nd Artillery Corps assessments, and in at least 4 other capitals we will not name in this video. They are not studying whether it works. They studied that 15 years ago. They are studying how deep to build. We have not yet told you what finally worked against Iran's program. Here is why that matters. The answer was not a weapon, it was an engineer. And what that engineer built caused more long-term damage to Iranian nuclear capability than 30 years of military planning, while simultaneously handing Iran the most valuable engineering feedback document in the history of asymmetric warfare. When a 30,000-pound bomb cannot reach the target, the instinct is to build a bigger bomb. America had a different answer, and it cost far more than anyone has publicly acknowledged. Stuxnet was not a cyber attack. That framing undersells it by an order of magnitude. Stuxnet was a precision-guided munition delivered through a supply chain instead of an F-15. It was engineered with the same systematic logic as the GBU-57, targeting a specific physical system at a specific facility to produce a specific mechanical failure, except it traveled on a USB drive and detonated inside a centrifuge spinning at 1007 Hz. Estimated $1 to $2 billion, joint American-Israeli investment across approximately 4 years. Compromised Siemens industrial control software, introduced through contractors with access to Iranian procurement networks. 1,000 IR-1 centrifuges destroyed by being commanded to spin beyond their mechanical tolerance limits while reporting normal operation to Iranian monitoring systems. 18 months to 2 years by most independent assessments. Cost per destroyed centrifuge, $1 to $2 million. Cost per GBU-57 strike on the same facility, $3.8 million per sortie, with a confirmed inability to reach the centrifuge halls at all. Stuxnet was 6 times cheaper per unit of damage delivered, and it was the only option that reached the target. Here is what the mainstream account of Stuxnet consistently omits, and this is the part that changes how you read everything that follows. Iran used Stuxnet as an engineering specification, the same systematic logic Hamas applied to Israeli bomb damage assessments: study what the enemy sent, calculate what it reveals, build the response before the next attack arrives. Iran applied to the most sophisticated cyber weapon ever deployed against an industrial system. They reverse-engineered Stuxnet's code. They identified exactly which vulnerabilities in Siemens' SCADA architecture had been exploited. They isolated exactly which operational security failures had allowed the delivery. They documented every decision the engineers had made. And then they built one of the most capable offensive cyber programs outside the Five Eyes intelligence community, funded, structured, and targeted specifically using the attack that was supposed to destroy them. America ran Iran's cybersecurity graduate program for them at a cost of $1 to $2 billion. The tuition produced a program now assessed by CISA as a persistent threat to American critical infrastructure, power grids, water treatment, financial systems. The solution to the mountain problem cost $2 billion and created a $2 billion problem. The facility is still operational. The centrifuges have been replaced and upgraded. Fordow now runs IR-6 centrifuges, 9 times more efficient than the IR-1s Stuxnet destroyed. The program setback has been recovered with interest. Iran used the attack as a construction specification. Every vulnerability Stuxnet exposed told them exactly how to build, exactly which systems to harden, exactly where the next intrusion would attempt entry. America paid $2 billion to run Iran's quality control program for them. Here is what 30 years of Iran-America strategic confrontation demonstrates, not to historians, but to every defense ministry, every engineering faculty, and every asymmetric warfare strategist currently running the next calculation. Geology is a weapon, not metaphorically, financially, strategically, geologically. $20 billion of mountain-based construction absorbed $100 billion in American strategic expenditure, neutralized the most expensive conventional bunker buster ever built, forced a diplomatic framework that no military option could produce, and generated an offensive cyber program from the attack designed to replace military options that had already failed. The GBU-57 reaches its limits somewhere inside Iranian granite. Iran built beyond that limit before the GBU-57 existed, using American procurement timelines as a construction schedule and American strike assessments as a depth specification. Stuxnet reached its target and taught Iran how to make sure the next one would not. The next facility is being built at 120 meters. That calculation is already complete by engineers who learned exactly what depth to choose from the weapons sent to stop them. And the next Stuxnet is already built by the program that learned exactly which vulnerabilities to close from the attack designed to destroy it. Subscribe to Future Blueprint. We will be there when both surface. We don't cover wars, we cover the engineering underneath them. Blueprint filed.